This video will introduce you to the STAR Lab system, to the basic requirements to use the portable planetarium, and it will demonstrate an example astronomy lesson using the Starry Night program. The STAR Lab Portable Planetarium is a portable planetarium system that is a fully immersive educational experience to learn about astronomy and other topics. The system consists of an inflatable dome and a compact, manually operated and user-friendly projection system. The components of the system that you need to set up your inflatable planetarium are a duffel bag with an inflatable dome, an air pump, and a hard case with a digital projection system. It is recommended that the system be set up by 2 people. The projection system comes in the hard case. The hard case contains a digital projector, a Mac laptop to operate the projector, 2 speakers, and cables. The hard case becomes the stand for the projection system that goes into the portable planetarium. Setting up the planetarium. In order to set up the planetarium in your space, you need to keep in mind certain considerations and requirements. The space requirements are: you need to have a minimum ceiling height of 10.5 feet. You need a clear floor space of 21 feet around the center of the planetarium. The planetarium or the dome can fit in most classrooms, or you can also set it up in a cafeteria, in a gymnasium, or other large spaces. It is recommended that you have a clean floor, and carpet is ideal to set up the inflatable dome. Other considerations when you set up your planetarium are that the dome blocks light, but it doesn't block sound. So when you're running your planetarium show, you want to make sure that the room is quiet otherwise. You're going to need 2 outlets that are needed for connecting the blower and the projector. You also need an extension cord to connect either the display system or the blower. The dome has no temperature control, but it has constant air circulation. Setting up the planetarium. In order to set up the planetarium, to inflate the dome, and to set up the digital projection system, please refer to the manufacturer's videos on this subject. Now, we will demonstrate an astronomy lesson that you can use in the portable planetarium. This video will demonstrate an example astronomy lesson to be used with the STAR Lab portable planetarium system. We will be using the planetarium software called Starry Night Small Dome. This lesson is geared for grades K through 4th, but it can be used at any grade level, and you can modify it in any way that you wish. The lesson is meant to demonstrate the basic use of the planetarium software and give you an idea of what types of presentations are possible. We won't cover all the topics or all the lessons available, so please have a look at the available lessons in the program for more content. This is a short demonstration of the basic controls of the Starry Night Small Dome program. So this is the main screen that you're going to see when you first open the software. What you're looking at is the sky that is simulated onto the projector dome. So you have a full view of the sky that you are projecting and the options that you are displaying at all time. And you have control of the date and time that is displayed, the flow of time, the place and location on Earth, and the view of the night sky. So The first option that we have in the Starry Night Small program is to change the date and time of day that is displayed. So for example, this is the sky at January 1st, 2001 at 6:39 p.m. We can change the time by clicking on the numbers and inputting whatever number we have with our keyword, whatever time we want with our keyboard. We can just change that 6 p.m. for example to 8 p.m. I just pressed 8 with my keyboard and it went to 8 p.m. If I want to change the month of the year, I click on the month so that it's highlighted, and then I use my keyboard up and down arrows to move through the different months of the year. So I can go and choose any month I want. If I want to change the date of the month, I click on the number 1 until it's highlighted, and then I choose whatever date I want with my keyboard. And then the same thing with the year. I can type in the year with my keyboard or use the up and down arrow buttons in my keyboard to move through the years. Right, 2002, 2003, I can choose whatever year I can. If I want to go back to present time, I can always click on the now button, which brings me down to whatever time it is now in my computer. I can also fastly go to sunrise or sunset of that day by clicking the sunrise buttons or the sunset buttons. Let's go back to now. Now, the sky is going to move according to the regular flow of time. So the stars are going to revolve around the night sky according to the rotation of the Earth. So typically the flow of time is set to real time. So that is 1 second per second is passing in our simulation. You can choose to speed up time by 30 times, for example, 300 times, 3,000 times, and 30,000 times. So for example, if we choose time to go faster by 30 times, we can start to see that the sky, right, revolves around the north celestial pole. If we set the flow of time to be 300 times faster, now we can see the rotation of the sky more clearly. So if I want to stop time, I can hit stop. If I want to continue with the flow of time, I can hit play. Okay, I want to hit stop right now and go back to real time. I can also have time move in discrete time steps. So for example, let's say I want to move my simulation or see the motion of the night sky every hour. So I would set discrete time steps at 1 hour and then use the move forward button to move my time forward by 1 hour. And you can see that the time here changes from 12, 1, 2, etc. Right? I can always back to real time and to now with my controls. Now, we can set the position of Earth from which we are observing the night sky. And this is very important because the position of Earth gives you the position of the horizon. The sky is going to be different depending on your position on Earth. Right? And the constellations you observe are going to be different depending on the position on Earth. So right now we have it set to Charleston, but you can also change that as you wish by hitting other in the viewing locations menu. Now, with my mouse, I can move my display around to orient it in different ways. Right? For example, I have the north coordinate facing the bottom, right? And the south coordinate facing the top. I can change that with these controls. I can put the south coordinate in the bottom of my screen, or I can choose any other orientation that I wish to see in my simulation. So let's go back to north orientation in my screen. Now, in the left side of the screen or the window, we can see our main menu of activities and configurations for the Starry Night program. So first of all, we're gonna hit options. And then in options, you're gonna see some different menus. So the first menu you're gonna see is guides. So guides can change the display setting in your night sky. So for example, the most useful setting in this guides menu are the display of the ecliptic, which gives us the path of the sun around the earth, right, or throughout the year in the night sky, and it gives us roughly the position of the planets in our night sky. And we can also select a grid option, which gives us an idea of the coordinates in the celestial sphere for that configuration, for our date and time configuration. So right now, I'm going to deselect those options and just leave the night sky as is. Now, we can select our local view. We can select to have daylight, which means that if the time is set to a daytime, then we will see the sun and we will see the sky illuminated by the sun. So let me demonstrate that. Let's go to sunrise. So as you can see, when we go to sunrise, we're gonna see just a regular daytime simulation. If I click on daylight, we're gonna lose the daylight, but that would be what the sky would look like if the sun wasn't out in the sky. But notice, be mindful of the time. It's still 7 a.m. and we are still at sunrise. It's just that we have selected to get rid of the daylight. Now, as you can see in our simulation, we can see the horizon, and the horizon has simulated mountains and clouds to make our simulation or our view of the sky more realistic. This can also help our students realize that we are looking at a 360-degree view of the night sky or of the sky. But if we want to remove the horizon markers like mountains and clouds, we can deselect local horizon, and then we would have no earthly horizon markings. For now, let's leave the horizon on. And let's go back to now, which is our night sky. Now, in the following menus, we have solar system, stars, constellations, and deep space. This allows us to select the objects that we want to see in our simulation of the night sky. For now, I have only selected planets and moons of the solar system, stars, and that's it. Later we will see how to select constellations if we want to have a lesson about constellations or other objects that might be of interest. But the simplest display of the sky is going to be just the stars and the planets of the solar system and the moon. In order to get rid of this menu, we can just click on the options menu and then it will be hidden in the left side of the screen. To bring it back, you just click on it again. To hide it, you click on the options menu again. One of the most useful features of the Starry Night software for a planetarium show is that you have a lot of educational resources. I'm going to show you a couple of resources that you can use for your planetarium shows that demonstrate different astronomical phenomena. So you're going to go first of all to favorites, and in the favorites tab you're going to see that you have a folder of simulations that contains a variety of simulations about different um, astronomical objects and observations. So you can find simulations about, for example, Earth, Moon, and Sun system, which would be, for example, simulations about the seasons, the moon, or eclipses. And you can also find simulations about the solar system, the planets, stars, and the galaxies. And for example, let me show you one simulation about lunar eclipses. So if you want to show a small simulation or a small video about lunar eclipses, you can show this in your planetarium show. So we're going to hit, for example, lunar eclipse from the sun. So if we click on lunar eclipse for the sun, we would get the view of a lunar eclipse from the perspective of the sun. So, and if you wanna have control over the simulation, we can hide our tab, our favorites tab, and use the controllers, the time control, to move time ahead to see the moon going behind the earth or crossing the shadow of the earth into a total lunar eclipse or a partial lunar eclipse. So you can demonstrate eclipses, and not only lunar eclipses but solar eclipses and other phenomena. If you want to go back to your regular planetarium display of the night sky, you can hit the now button, and then that brings you, the home button, and that brings you back to our regular planetarium view. So going back to favorites, besides these simulations, if you go down, you're going to see that there's a folder that is named movies. So in order to see the contents of the folder, we click on the arrow next to the folder, and you can see we have a series of movies that we can play in the planetarium dome and show our students. So whenever you play a movie on your dome, you want to make sure that your students are sitting down in the correct orientation facing the movie in the dome, and you're gonna see where the movie is gonna be projected by hitting play on whatever movie you want to play. So for example, let's take a look at the movie about asteroids. So the control for the movie are gonna be next to the name of the movie down here. The menu controls are going to be down here, so in order to play or stop the movie, we're not going to use our main controls of our sky simulation. We're going to use these individual controls that stop or play a single movie. So we're going to go ahead and press play in our asteroids movie. And as you can see, this is going to play in one side of the dome, so hopefully all of the students that you have inside of your dome can sort of fit on the opposite side of the dome in order to face the side where the movie is playing. The StarLab's portable planetarium system has available lesson plans that are guided and easy to use for any instructor guiding a planetarium experience. You can access the lessons through the Starry Night software. First, we start on our main screen. If we go to our left side menu, we see that we have a tab called Sky Guide. When we click on Sky Guide, we have access to all of the StarLab's curriculum, lessons, and materials. We have three main components that are available to us. First, we have StarLab student lessons, that are lesson plans for grades K to 12. We also have Astronomy of the Americas, which gives you an introduction to astronomy relating to history of the Americas. And then we have another main component about orders of magnitude. We also have an introduction to the basic components of the Starry Night program if you want to review any of the basic components. So for now, our lessons or our example lessons are going to focus on StarLab's student lessons that are specifically developed for students in grades kindergarten to 12. So as you can see, once we click on student lessons, we are taken to this menu where we have 3 links and the lessons are separated by grades. So we have primary school lessons for grades K to 4, we have secondary school lessons for grades 5 to 8, and finally we have advanced lessons for grades 9 to 12. I should say that even though these lessons might be in a certain category, a lot of these lessons might be interesting for students of all ages. If you want to go back to the main menu, you can always hit the button showing our home button here, and then if we click that, we go back to our main curriculum menu. This is a demonstration of a guided planetarium lesson using the presentation guide in the Starry Night software. The topics in the lesson are day and night and the rotation of the Earth. The lesson is geared towards students of grades K to 4, but it can be used and adapted for audiences of all ages. So, we start our lesson by finding the guide in the Planetarium software. We're going to go to Sky Guide, click on Sky Guide, and then we're going to see a menu where first you're going to see the welcome screen that says Starry Night Sky Guide, which has all the curriculum options. We're going to click on StarLab Student Lessons, and then we're going to click on Primary School Lessons, grades K to 4th. So we're going to see that for this level, we have 4 lessons available. So this video is about the first part of the lessons, which is about night and day. So in order to start with the lesson, we click on night and day, and we're going to be able to control our time with our main toolbar, which is over here. Right? So this controls the time flow of the presentation of the planetarium. So we start with the introduction, and then here we welcome our audience, welcome everybody to our planetarium. We can tell them that our planetarium is a special place that allows us to show what happens in the sky, and we can show the sky at any time of the day in any date that we want to choose. And we can also show the sky in the daytime or at night. So today we're going to look at what causes the day and night here on Earth. So first of all, the planetarium is like a time machine. We can set it to any date. So take a look at the sky around you. So is it nighttime or daytime? How do you know? Is the sun out or is the sun below the horizon, or is the sky dark? So now, what do we get from the sun? If the sun is out, what do we get from the sun? We get light and heat from the sun. Now, to continue with our lesson, we click on the following part, which is daytime. And remember, this is the projected screen in the planetarium. So right now, the students in the planetarium are going to be seeing the sky in the daytime configuration. So right now, the date, for example, for this example is set to June 22nd, 2006 at 2 p.m. So now, we can ask questions to the audience. For example, the guide gives you example questions that you can ask your audience to make the lecture or the lesson more interactive. We can ask, if we didn't have the sun, what would happen? What would happen if the sun wouldn't come out every day? And then that would mean the earth would be a very cool and dark place. So let's speed up and see what happens. So we're going to speed up with the play button, and that's going to move time forward in our simulated sky. Now we can see that the sun gets close to the horizon when the clock hits about 7:30 p.m. Right now, the time is moving a little bit slow, so maybe we can switch our time to move in intervals of hours, and we can move it to be close to 7 p.m. This is 4 p.m., 5 p.m., 6 p.m. So notice that when the time is around 7 p.m., the sun gets closer to the ground. So that means that the sun is going to start setting below the ground. What happened to the sun? It got closer to the ground. If we speed up time again, what do you think will happen? Let's see what happens. The sun is right at the level of the ground, and then if we go to 8 p.m., it's starting to get dark in the sky. The sky is starting to get dark, and we can see stars start appearing in the night sky. Let's go to 11 p.m. and now we can see that after the sun has fully set, we can see our dark night sky with all the stars starting to be visible. Now, is it daytime or nighttime? How do you know? Well, the sun is gone, so the sky is dark and the stars are out. How will you know that it's daytime again? How do we know that it's daytime? Well, we have to wait a few more hours, and we know, for example, that the sun will start rising above the ground, and with it, it will bring light to our earth, and then the sun and the sky will be illuminated again. So let's speed up again and see what happens if we move forward a few hours. We can see that the sun starts to rise above the ground, and then we have daytime again. So now we can ask, is the sun in the same place where it set the night before? So we saw that the night before, when it was 7 p.m., the sun was setting on this side of the sky. And now in morning time, notice that the sun comes out on the other side of the sky. Now let's move forward with our lesson. We're going to click on horizon. And this is a lesson about the horizon. So the place where the sky and the ground meet is called the horizon. So if you look carefully, you'll see that there are letters along the horizon. So we have the letter N, W, S, and E. Does anyone have an idea what these letters stand for? So these letters represent directions. E is for east, S is for south, N is for north, W is for west. Can everybody point to the north? Can everybody point to the south? Awesome. Each of these letters or combinations of letters represents a different directions along the horizon. Let's try a little game. Everybody now point northeast. Northeast is halfway between north and east. So you will find the northeast over here signaled by the letter NE. Okay, now let's go back to our sun. In which direction is the sun rising? Let's speed up again and watch the sun rise. So let's do the play button. Whoa, time is moving too fast for us. Let's go back a little bit. So let's go back to real time. And let's, oh, that's going to be maybe a little bit slower. We can choose maybe 300. And let's see the sun move. Or we can do also intervals. Let's do intervals of hours. And which seems to work better for us. So now let's go back to noon. Actually, let's go back to the morning, 1 second. And let's see what direction is the sun moving towards to. So let's move forward in time and see. So notice that the sun seems to be going all the way from the east or the northeast, and it goes around all the way to the northwest or close to the west. Now let's go back to noon. So that is about noon. Where is the sun? Well, the sun is almost overhead, but a little bit towards the south direction. So if we continue to speed up time, can anybody guess which direction the sun will set? So we already got a peek of that, and the sun is going to set on the other side of the horizon, on the other side of the ground towards the west, or in this case the northwest. So we just follow the sun completely for 1 day. A full day takes 24 hours and includes both the daytime and the nighttime. As we watch the sky, the sun, it looks like the sun is moving across the sky. So initially, it looks a little bit like the sun is moving around the earth. It looks like we are standing still and the sun is moving around us, and then we see it go up and down in our sky as the sun goes around the earth. It turns out that there's something going on, there's something else going on, and there's another idea of what's going on. The sun is not moving around the earth. It turns out that we see the sun move around the earth, around the sky, because the earth is spinning. It's us that are moving. So as the earth is spinning, the sun appears to move around the sky, going all the way from the east horizon to the west horizon. So it's us that's doing the moving. Now, to continue with our lesson on reasons for day and night, we click on number 4. And now we can tell a little bit about the history of the ideas about the motion of the earth and the sun. So back in 1543, a long time ago, a famous scientist called Nicholas Copernicus came up with the idea that the earth was moving. Not the sun was revolving around earth, but instead the sun was not moving, and instead the earth was spinning. And not only was it spinning, but it was moving around the sun. Many people did not believe it because they did not feel the earth should move. And also it appeared that the earth was not moving. Today we know that we can't feel the earth spinning because it's so big. Let's see how the earth's motion controls day and night. Now we can show the earth in space. So now we go here to the action box, and then we go to show the earth in space, which gives us a simulation of the earth from the point of view of outer space. We can see where the sun is located because the earth is illuminated on the right side, so the sun has to be on the right side. And then we're going to see how the earth spins around in space. So here we are about 11,000 kilometers out in space looking back at the Earth. Does the Earth look the same on both sides? No, half of the Earth is lit and the other half is dark. Why do you think that one side of the Earth is bright? The sun is shining on half of the Earth. Where the sunlight hits, it's light up. Half of the Earth is being lit up by the sun's light. On that part of the Earth, it is daytime. So if we are standing right here on this part of the Earth, we will see our sky be illuminated by the sun's light and it will be daytime. On the other half of the Earth, there's darkness. That is nighttime. So if we were standing on this side of the Earth, then it would be night for us. So everybody point in the direction of the sun. Now watch what happens as we move forward in time. So as you can see, the Earth spins around as day and night progresses. So what you're seeing is the rotation of the Earth. The motion that you're seeing is called rotation. So even though we don't feel it, the Earth makes one complete rotation every 24 hours. And 24 hours is one full day. Watch the continent, the green part of the Earth, as the Earth spins. We can also move the Earth in discrete time steps of 1 hour and watch it spin around as some parts of the Earth go from day to night and again back to day and night. Can you see when they are in day and night? Based on what you are seeing, does the sun appear to move? It doesn't seem like it. It seems like the sun is always in this direction, towards your right, and Earth, meanwhile, is spinning around as it moves around in space. Now, to finish our lesson on day and night, we click on part 5, Earth and Sun. And now we're gonna click here to zoom further out into space. So now we're gonna travel farther out into space. Let's see. Now we are over 200,000 million kilometers away from Earth. Now this is Earth. This little dot over here is Earth, and here's the sun. Now you can see where the sun is relative to Earth. It was on the right side. So based on what we saw today, can anybody explain why we have day and night on Earth? So day and night happen because the sun shines on only half of the Earth at a time. So the light from the sun travels all the way from the sun to Earth, so that half of the Earth is illuminated and the other side is in the shadow, so it's in darkness. The side of the Earth that is illuminated is going to be the daytime, and the side that is dark is going to be in nighttime. As the Earth rotates or spins around, different places in the Earth move into the lit and the dark areas. So this is the end of our lesson for day and night. And as you can see, we can always continue with the lesson, which is about moon phases, for example, or we can always go back to our main menu by hitting the home button in the upper part of the menu here, go to the home page, and from there we can start any new lesson that we wish. So this is the end of our example lessons. As you can see, the Starry Night software, along with the portable planetarium, allows any instructor the tools to successfully lead organized and interactive lessons about many topics in astronomy. We hope you can bring the stars into your classroom. Thank you for watching.